Okay, so we started this unit by talking about square roots of perfect squares. And a perfect square is a number that you can write as some other number times itself. Normally, when you guys think of perfect squares, you think of whole numbers, like 25, because 25 is a perfect square because we can write it as 5 times 5. 100 is a perfect square because we could write it as 10 times 10. Remember, fractions, and therefore decimals, because decimals is just another form of fractions, can also be perfect squares. Like 1 over 4 can be written as 1 over 2 times itself. Okay, so the fraction 1 over 4 is a perfect square. The decimal 0.36 can be written as 0.6 times itself. So 0.36 is a perfect square. And then we practice taking some square roots of those perfect squares. So now we're briefly going to talk about non-perfect squares. Well, if a perfect square is a number that can be written as some other number times itself, a non-perfect square are numbers that are not perfect squares, or they cannot be written as another number times itself. So therefore, we can't find the square root of non-perfect squares exactly, because there's just no number times itself that gets us that number. So we can only estimate their square roots. And because of this, and this goes back to something we talked about in the second unit, okay? Non-perfect squares, like if you tried to take, say, the square root of 5 on your calculator, you would get 2 point, and then you get a whole bunch of decimals. And actually, those decimals never repeat and never end, okay? And we talked about those kind of numbers in the last unit. And those are numbers, if they never repeat and never end, you can't write them as a fraction. And remember, a rational number is a number you can write as a fraction. What do we call a number that you can't write as a fraction? Irrational numbers. Remember, we said that pi was an example of an irrational number because it never repeated and never ended. There's actually a whole bunch of other irrational numbers. The square root of 2, the square root of 3, the square root of 5, 6, 7, 8, 10. Why did I not say the square root of 4? Because it's 2. Why did I not say the square root of 9? Because it's exactly 3. Okay, good. All right, so how do we estimate these things? Well, there's a couple of ways we could do it. One way is without using a calculator, and the other way is just punch it into a calculator and round it. Okay? So if we try to do it without a calculator, we can do something called benchmarks. So like, let's say we were asked to find the square root of 12.5. That's not going to give us a number that repeats or ends. That's going to give us an irrational number if we tried it on a calculator. So the best we can do is estimate it. Well, here's how we go about it. Okay? Draw a number line where we go a few numbers below this and a few numbers above this. Is there a number on here that you can take the square root of exactly? Yep, 9. So if I took the square root of 9, what would I get? Is there another number on here that we can take the square root of exactly? 16. And if we take its square root, we get 4. Well, here's 12.5, right here. If we tried to take the square root of 12.5, wouldn't our answer end up somewhere between 3 and 4? And whereabouts between 3 and 4? About halfway. So we could say the square root of 12.5 is about 3.5. If it was over here, maybe we'd say 3.7 or 3.8. If it was way down here, we'd maybe say 3.1. Okay, but that's how you can use benchmarks. And if you actually plug this in on your calculator, you would get, and if you round it to 1 decimal place, and you should know, by the way, how to find the square root on your calculator. So if I took the square root of 12.5, I would get, if I round it to 1 decimal place, and then we use these 2 wavy lines, mean it's approximately. I actually get 3.5, so I estimated it mentally quite accurately. So you're not really going to be responsible for doing benchmarks. And technically, you don't even have to do benchmarks. You can do it without. But for the most part, when we do these things, when we use these things in actual problem-solving situations, we're going to use calculator. Okay. So a couple of examples. Find the square root of 20.1. Well, we want to set up 2 lines. One where we have numbers, one where we take the square root of the numbers. So we don't have to put in a whole bunch. Okay. Tell me what number below 20.1 could you take the square root and get an exact answer? 16. So let's start with 16. What about what number above 20.1? 25. So let's count from 16 to 25. 17, 18, 19, 20, 21, 22, 23, 24, 25. I know the square root of 16 is 4. I know the square root of 25 is 5. Well, where's 20.1? 17, 18, 19, 20. So 20.1 will be just a little right to this notch. This will be 20.1. Therefore, what do you think its square root will be? According to this number line. 4. Yeah, again, about 4.5. Even if you said 4.4, you're pretty close. Okay. The second one. What might be easier to do with this second one? Convert it to decimal. Because it's easy to work with them when they're in decimal. So what's 9 over 5 as a decimal? 9 divided 5. 1.8. So that's a little easier to deal with. And again, let's start with a perfect square below and a perfect square above. What number below can I take the square root of exactly? Below 1.8. 1. What number above? 4. So 2, 3, 4. So I know the square root of 1 is 1. I know the square root of 4 is 2. And where's 1.8? Well, this is 2. 1.8 is somewhere around here. So its square root must be somewhere here between 1 and 2, which looks like it's about, where would this be between 1 and 2? What would you say? 1.3-ish, yeah. Cool. Oh, 1.3. And again, we could confirm those ones using a calculator. Right? Which is really, once we use these things in a problem-solving situation, which we're going to be later in this lesson, we're going to use a calculator, not benchmarks. This next one's a bit of an interesting one because you got to think about it. Write a decimal number so that when you take its square root, the answer is between 10 and 11. Give me a number. So 1.5? 10.5. What's the square root of 10.5? Use calculator.
3.2.
Is that between 10 and 11? No. So you're not asked to find a number between 10 and 11 to take its square root. You're asked to find the number that when you take the square root, you get between 10 and 11. Okay? 111, what's the square root of that? One decimal place.
10.5.
That works. How did you know to go to 111?
It was 100 square root is 10.
Exactly. If you think about it, the square root of 100 is 10. Well, I must have to go above 100 to get a square root answer greater than 10. But I can't go as high as the square root of 121, which is 11. So I need to take a square root of some number between 100 and 121. So 111 works. 115.7. 119.35. You got tons of numbers to pick. Okay? So any number between 100, which is 10 squared, and 121, which is 11 squared. Okay? That would be your answer. Okay. So where's one area that we use square roots? You should be familiar with this. Pythagorean theorem, or the Pythagorean theorem. I don't know how they pronounce it. I don't know what the proper pronunciation is. Anyway, invented by a guy who I guess was so cool, he only had one name, like Cher or Madonna. His name was Pythagoras. I don't know, maybe he had a last name, Pythagoras Smith or something. Pythagoras Jones or something. I don't know. I'm just sort of talking rambling now. Anyway, do you remember what this formula is?
A squared plus b squared makes c squared.
Right. Okay. So the Pythagorean theorem states for any right term, one of the legs squared plus the other leg squared
will equal the longest side square.
What do we call that longest side? What's the name for it? Not the base. Begins with an H.
The hypotenuse.
Yeah.
Hypotenuse. Hypotenuse.
What's that? Oh. Well, that's not nice.
I remember them.
You could just call it the longest side if you. Okay.
And so, and then there's two other sides, obviously, in a triangle, and they are the legs. How do you know?
How do you find the legs in a right triangle? They're the two sides that make up the right angle.
So like if I said,
Tell me a leg.
One.
Tell me a hypotenuse. Tell me another leg. Right. Okay.
so the legs always make up the right angle, and then by default,
The other side must be the hypotenuse.
okay? So like in this triangle below, C is the hypotenuse. And A and B are the legs.
So, and why do we use this formula? Well, it helps us find missing sides in right triangles. Why is that so important? Because if you look around, much of what is constructed in society is made up of triangles. Okay? A triangle is probably the strongest shape whenever you construct something.
Like imagine if I, up here, if you look up here, you see there's a couple of beams like that. And we see that it looks like that. If I didn't have these, and I just had,
Vertical bars, that thing would collapse. Okay, eventually, because that's not very strong.
once I put a triangle in here, it makes it way stronger and prevents it from collapsing.
So that's why we use triangles a lot.
That's why a triangle is very important when we talk about things like engineering and architecture.
And design.
Extremely important shape. Okay, so let's do some examples.
Here we have a right triangle.
You're given two of the sides, you're asked to find the third one, so what I would suggest you do is write the formula first,
And then fill in what we know. What would the formula look like after I fill in what I know? Gracelyn? Right. Now what do I do?
144 plus 29.
okay? And then? Is that all we do? Okay, so maybe what we should do is say, okay, this is C squared. So you're right, if I add those together, I don't get C.
I get C squared. How do I find C?
Okay, I'll take that to mean square root. Correct. And we get 13, don't forget your units.
Centimeters, exactly. So that one turned out to be a perfect square when we did that example. Okay? It's not going to happen every time.
For example, the next one.
What would this look like after I plugged everything I know into the formula?
A squared plus b squared equals c squared.
C squared plus, one of the, because,
Okay?
All right. Do I know one of the legs?
Or do I know both of the legs?
you know, one.
I know one of them. What is that?
So it's 4. So I'm going to plus 4 squared.
Do I know the other one?
No.
What is it called? It's not called B if you look at the diagram. It's called X. So don't write B, write X, because that's what the diagram's telling us to do. Which means I must know the hypotenuse. 9 squared. And now we just got to figure out what X squared is. Well, 4 squared is plus X squared equals 9 squared, which is 81. Now what do I do?
Subtract, 16 from the one.
Right. Bring the 16 over here by subtracting 16. And we get x squared equals 65. That's not a perfect square. Well, I won't put that one just yet, because we're going to find it by taking the square root of 65, which is approximately 8.1 if we round it to 1 decimal place, millimeters.
Good.
Okay, let's take it a little further.
First of all, I don't want to talk about that. We don't need to. We're just going to go ahead and do the last couple of examples. All right. This one. You're locked out of your house. The only open window is on the second floor, 24 feet above the ground. You need to borrow a 25-foot ladder from one of your neighbors. There's a bush along the edge of your house, so you can't put the ladder right up against. You have to take it a little bit away. Okay? How far do you place it away, given this situation? Well, can you see the right triangle in this diagram?
Yeah, it's made up of the ladder, the distance on the ground from the bottom of the ladder to the bottom of the house, and part of one of the walls. I know this length is 24. I know this length is 25. This is what I'm trying to find.
So if I don't know what it is, what would you like to call it?
Sure.
You can call it whatever letter you want.
Well, because we're dealing with a right triangle and we're finding the side,
We're going to use Pythagoras. What does it look like when I fill everything in?
24 squared, x squared equals 25 squared.
And now we're ready to figure out what x squared is. So first of all, we have to do 24 squared.
576 plus x squared is equal to 625. I got to bring the 576 to join the 625 by subtracting. So I get x squared equals 49. X is going to be the square root of 49. which turns out to be exactly 7, don't forget the units,
Feet. Okay?
and the last example. You all right? Why does it look like weird? It's a ramp. Do you feel threatened by ramps? Do you? Is that what ramp talk is all about? Hey, let's build a ramp. Let's run around and up and down on ramps. And then you fell and just started.
Yeah.
I can see why ramp up might be a problem. Okay. So the sloping face of a ramp is to be covered in carpet. So this here, we're not going to cover the sides or the back or the bottom. Just that's going to be covered in carpet. Well, in order to figure out what that's going to be, I've got to do something first. Because I know this is 2.2, but I don't know what this is. Okay? All I know is that the ramp is 1.5 meters high at its highest spot, and it's 6.5 meters long, but that's not the length of the ramp. Okay? This is the length of the ramp. This is what I'm trying to find. So for A, we need to find X. And we use this right triangle to find it. So using Pythagoras, using the formula, what would it look like when I plug everything in? Equals. But what have I called it? Excellent, good. Now you can save yourself a little bit of time. You can save yourself a little bit of step. Why don't we do this all together? So 6.5 squared plus 1.5 squared. That would be. No, I need my calculator for that one. 6.5 squared plus 1.5 squared is going to give us 44.5. I was just saving a step. You don't have to. You can do these separately and write it here and then put it together. That's fine. So how am I going to find X? Square root of 44.5. And it's asking for the nearest 10, which is 1 decimal place. 6.7. Well, 6.667. I did not do that on purpose. I swear to God. So now I know that this is 6.7. Here's a question. Is the top that we're carpeting a rectangle or a parallelogram? Oh, it looks like it, but in reality,
It's a rectangle.
it's a rectangle. Because if you get a ramp, well, that's not. If you get a ramp like that, while it looks from a certain perspective like a parallelogram, if you look straight down on it, it's a rectangle. So therefore, to find the area of the carpet, what am I going to multiply?
Base times height.
So 6.7 times 2.2. 14.7. 74. 74. Are you done? Meters?
Square.
Yes.
Did somebody say pie?
No.
Oh, I thought somebody said fine.
Maybe I will.
Okay, I have no clue what you just tried to say.
Said I love pie.
Oh,
Exactly.
what's your favorite pie?
Oh, well, I've never had a pie before, but
Are you kidding me? You've never had pie before, but you love pie.
I didn't say I love pie.
Oh. So you don't like pie?
No.
You've never been in a situation where somebody said, hey, want a piece of pie? Never? You've never been to a family dinner like Thanksgiving where, hey, guess what we got? We got some pumpkin pie.
I love
You've never walked by a house and seen an apple pie cooling in a window thinking, oh, I think I'm going to take that pie.
it's just like looks so weird, but I don't want it.
Yeah, it looks like a circle. So you're afraid of ramps and circles.
No, that's why I don't like raspberry ones. No, I'm kidding. I love that.
Why do you hurt me? Why must you hurt? Because now I have to go, you know, the closest men's washroom is on the main floor. So I have to go all the way down there to go in there and cry. Because you hurt me.
I'm kidding.
I see what people are now. You ever look at them?